All right. Let's get to it. Today marks day 13 of my journey to learning cybersecurity using TryHackMe.com structured learning paths to get the job done. So far, we have been completing quite a bit. Linux fundamentals, start your journey, Windows and Active Directory fundamentals, the command line, networking. Then we have TCP dump and nap dump. And quite a bit more to get through, but I'm looking forward to having a good time. And obviously, for those that follow along, I love to supplement my learnings with additional readings. So yesterday spent quite a bit of time reading over the transport layer security, the origin server, and the edge server, and how they work and the role they play in performance and also network or internet security. So today we're going to jump into TCP dump. Let's make sure all of this is good. Let's do 5. And make sure we got a little volume going here as well, so we are all good. All right. I did finish up the Windows Shark yesterday evening, but I didn't get a chance to jump online. It was a little too late. I was told that no more streaming for today, so my apologies for not displaying that. But Windows Shark is just a tool, so it's not something I'm overly concerned with, because as we get our hands dirty and we move away from tryhackme.com, that tool is one of the industry standards. So I expect to be getting quite a bit of experience with it. And of course, they have quite a bit of up-to-date documentation that I've seen online from yesterday. So I'll be sure to look into that as well. All right, got everything going. Let's get to this introduction. Let me adjust this. Make sure that looks okay. Which one is it? It's not that one. It's that one. Sorry, just want to make sure that this can be seen fairly clearly. So I think we are good there. And let's lock that down. And task 1, the introduction. The main challenge when studying network protocols is that we don't get a chance to see protocol conversations taking place. All the technical complexities are hidden behind friendly, elegant user interfaces and access resources on your local network without ever seeing an ARP query. Similarly, you would access the internet services for years without seeing a single three-way handshake till you check a network book or inspect a network traffic capture. The best study aid would be capturing network traffic and taking a closer look at the various protocols. This helps us better understand how the network works. This room introduces some basic command line arguments using the TCP dump. The TCP dump tool is libpcap library written in C and C++, and a release for Unix-like systems in the late 80s and early 90s. Consequently, they are very stable and offer optimal speed. The libpcap library is the foundation for various other networking tools today. Moreover, it's ported to Windows as WinPcap. Let's see what this is. WinPcap. So this is a WinPCAP for many years and has been recognized as the industry standard tool for link layer network access in Windows environments. Patient capped applications designed to capture, transmit network packets bypassing the protocol stack and including kernel level packet filtering, a network statistic engine, and support for remote packet capture. So this appears to still be something that's relevant today. WinPCAP consists of a driver that extends the operating system to provide low-level network access and a library that is used to easily access low-level network layers. Okay. Also contains a Windows version of the well-known libpcap Unix API. Thanks to its set of features, WinPCAP has the packet capture filtering engine for many open source commercial. Just standard link layer network access in Windows. Allows applications to capture and transmit network packets bypassing the protocol stack. Level packet filter. There's also the home of the popular TCP2. Windows popular TCP dump tool. Used to watch and so to disk network traffic according to various complex rules. So which one will it have us focused on? CC basic necessary to be done, in particular how to capture packets and save them to file set filters, and capture packets, control how packets are displayed. Prereq, the user must be familiar with this graphic done. Yep. Click start machine and it gave us a username and password. So that should be suffice to get going. What's up, brother? Appreciate it, man. The encouragement and kind words will do. I think that might be Joshua, but I could be wrong, man. I appreciate the love and support, man. Thank you. It means a lot. And I intend to keep going. Absolutely. Few minutes to finish loading up here, but this should be fun. Wow, that's loading. I can be bouncing around. Basic packet capture, filtering, expression, advanced filtering, displaying packets. So it seems like this is just going to be all of how to get comfortable with this interface. What is the name of the library that is associated with TCP dump? But it want the Windows on? I'm assuming lib bcap. No, it doesn't mean the Windows version. I think all of this is Linux anyway, but that's cool. I'm looking forward to getting my hands dirty with Linux anyway. Task 2, you can run a TCP dump without providing any arguments. However, this is only used for the tests that you have installed. In any real scenario, you must be specified about what to listen to, where to write, and how to display packets. Specify the network interface. The first thing to decide is which network interface to listen to. Using the -I interface, you can choose to listen on all available interfaces using -I any. Alternatively, you can specify interface you want to listen on, such as IETH0. Commands such as IP address show or merely IPAS would list the available network interfaces. In the terminal below, we see only one network card, ENS5. So it's referring to this ENS5, Q disk, and Q state, in addition to the loopback address, which is here. Save the capture packet. In many cases, you should check the captured packets again. This can be achieved by saving the file. Our extension is most commonly set to the .pcap. Save packets can be inspected later using another program such as Wireshark. Packet scroll. Read capture packets from the file. The TCP dump to read packets from the file using the .5. This is very useful to learn about protocol behavior you can capture. This is very useful for learning about protocol behavior. You can capture network traffic if it is suitable. Network time frame to inspect a specific protocol, then read the capture file while applying filters to display the packets you are interested in. Furthermore, it may be a packet capture file that contains a network attack that took place and you inspect it to analyze the attack. Limit the number of capture packets. You specify the number of packets to capture or specifying the count. Without specifying the count, packet capture will continue to interrupt it, for example, by pressing Control C. Depending on the goal, you only need a limited number of packets. Resolve IP addresses and port numbers. TCP dump will resolve IP addresses and print-friendly domains. Possible to similarly, you don't want port numbers to be resolved, such as 80 being resolved to HTTP. You can use the -NN to stop both the DNS port number lookups. You can show me the terminal. We captured and displayed 5 packets without resolving the IP address. So that will be here. Here are the 5 packets. And it does not have a IP address. Interesting. Interesting. Produce more verbose output. We want to print more details about the package. You can use the dash V to produce a slightly more verbose output. According to the TCP dump manual page, using dash V will print the time to live identification, total length, and options in the packet. So I'm gonna copy this because it's just teaching about how to use the tool itself. It's gonna be tough to get a good handle on how to use a tool in such a limited number of time. However, we may need to reference it, and that's why you always want to supplement your learning with things outside of the initial structure, because that's typically not enough. Consider the following cases: TCP dump -IO captures and displays 50 packets by listening on the ETHO interface, which is a wired internet, and displays verbosely. Dash I. It's going to list all. This should be a wireless, and the data PCAP. Let's see. Captures packets by listening on the WLIO interface, a Wi-Fi interface, and write the packets to this data PCAP. We continue till the user interrupts the capture by pressing Control C. TCP dump -I any and captures packets on all interfaces and displays them on the screen without a domain name. I remember reading that as well. We have it here. What option can you use to you? What option can you add to your command to display addresses only in a numeric format? So if we want addresses only, let's see. Hmm. Nope. Hmm. This is looking for TCP lookup. TCP dump numeric. Numeric. Is it N or dash N? Whoop, whoop. Filter expressions. Although you can run a TCP dump without providing any filtering expressions, this won't be useful. Just like in a social media gathering, you don't try to listen to everyone at the same time. You would rather give your attention to a specific person in conversation. Considering the number of packets seen by our network card, it is impossible to see everything at once. We need to be specific and capture what we are interested in inspecting. Number of packets seen by a network card, it is impossible to what's it? Filtering by host. Let's say you are only interested in the IP packets exchange with your network printer or specific game server. You can easily limit the captured packets to this host using host IP or host name. In the terminal below, we capture all the packet exchange with the example.com and save them to http.pcap. It is important to note that capturing packets requires you to be logged in as a root sudo. So you can go sudo tcp dump host example.com. If you want to capture all DNS traffic, we can limit the capture packets to those on port 53. 53 by default. The following example, we can see how the DNS queries read by a network card. The terminal below shows two DNS queries that find the first query request is the IPv4 address used by example.org, while the second request is IPv6 associated with example.org. So TCP dump -I, which is capturing packets on a specific network. ENS5, that was, I think we read about that here. Network card, okay. -C5-N. So that is limiting the count to 5, and then N. If you don't need to do a DNS lookup, you can use the -N argument instead of putting the port number there, which would give you this information back. Okay. right? So the format for this is, well, this starting with what was sudo again? Logical operators. Three logical operators can be handy and captures packets where both conditions are true. For example, TCP dump host 111 and TCP captures TCP traffic with the host quad ones, or captures packets when either of the conditions is true. TCP dump UDP or ICMP captures UDP or ICMP traffic. Not captures the packets when the condition is not true. For example, TCP dump, not TCP, captures all the packets. Oh, so it gave it to me right here. I didn't even have to write it out. It's in all interfaces and captures the TCP packets to a farm 422, i.e. SSH traffic, TCP dump dash I, wireless UDP port 123. Wi-Fi network card and filters the UDP traffic to port 23. The network time protocol, which is the NIPT, NTP. Mm-mm-mm. TCP port 443. We're listening for the Ethernet, the wire Ethernet, and the filter traffic exchange on example.com that uses the secure port 443. Well, it uses TCP and the secure port 443, I should say it that way. Remember that you can count the lines of piping the output via the WC command. In the terminal below, we can see that we have 910 packets with the source IP address set to 192.168.124.1. Excuse me. How many packets in the traffic.pcap using the ICMP protocol? That's this protocol, ICMP, 52 packets. What is the IP address of the host that asks for the MAC address 192.168? Hmm. So I wonder if it wants me to use this terminal, because it doesn't appear that it's coming from either of the examples, but yeah, I think it might want me to use the machine. That's even better. Let's do that. Using the intro. Let's go with start machine. A few more minutes, wait on this to finish loading up. So what we'll be doing once this comes up, I think we're already logged in. Well, I don't think we need to log in because we can do the root connection, which is -R. I think, I hope. Well, if not, we'll make do. So I think it is TCP dump -R, and then we want to look up the traffic dot pop pcap, excuse me, and then we want the ICMP protocol, and then I think we add the dash or the bar WC, right? So we see, or we got back the connection. So this says 26. Hey, there we go. What is the IP address of the host that asks for the MAC address of 192.168.124.127, 137? So I think for this one, the TCP dump dash R for root, and then to get the host IP, what is that command? Let's see, do I already have it? Filters packets by a specific source host. Is that what we want? Was it pcap? And then no, you gotta do traffic dot pcap, and then we want the command hmm. Let's take the hint. We're talking about filter by ARP. Filter by ARP. Filter by ARP. So I knew it's ARP, but I need to filter by it. Where are we? Um, Hey, there we go. So what did I type in wrong the first time? Oh, I misspelled traffic. Well, nobody ain't tell me that. So now we need to find the host that asked for the MAC address of this. Tell this address. Request who has this address internal, tell this address internal. So that's 192.168.124.148. Cool, I'll take it. What's next? What host name shell domains appear in the first DNS query? Oh man, hold on. Got a trade. So this one is looking for. Sorry, hold on a second. It seems AD got traded. Man, they got a haul for him though. For those basketball enthusiasts out there, AD's on the move again. He's going to Washington. Oh God, but I mean, hey, he's out there with Trace. So anyway, so this one we're looking for host name subdomain appears in the DNS query. What's he talking about? So I think with this one, I thought there was one for the DNS port number. I don't see it there. Oh, let me tell my son. Hold on a second. I know he's gonna come get me if I don't get him. Sorry about that. Got some big NBA fans in the house, so needed to make sure everyone knew what was going on. All right, back to business. So the host name subdomain appears in the first DNS query. So I think let's look and see. I think all we need to do is just add DNS at the end. But for some reason, I guess I didn't capture that command in my notes. DNS query. Now this thing kind of okay. So if we need to show everything, we do the TCP dump root, the page, and the port. So do we need to include the DNS? So that would be tcmp-r dump. Bring this back over. So I just change this to port 53 maybe? Nope. So we'll need a little more than port 53. Let's see if we can figure this thing out though. Oh, it wrote port. Let me try that. Port 53. Hey, we got something. So what is it looking for? Filtering and expressions. It wants to know the host name appears in the first DNS query. Mirrors rockylinux.org. That might be it. Mirrors. That is the first host name I see. Here's the command. Here's the first query. Reading the file from traffic pcap link. It's an Ethernet connection. I think this was the time. This is the IP address. Internal. This is the requesting. Internal. The domain. Mirrors, and this is Rocky. Yeah, it's got to be it. Mirrors. RockyLinux.org. Hey, we got it. We got it. We got it. All right, so advanced filtering. This is just getting comfortable with using this tool and doing different lookups. I expect to get more comfortable and efficient with this as we actually utilize the tool itself. But it's a good introduction, and obviously, you know me, if I can't find the answer there, I'm going to look it up. So thank goodness for good old handy dandy Google until I get enough hands-on experience to where some of this stuff becomes muscle memory or repetitive to me, if you will. But for right now, this is working and it is suffice. So let's look up or read about advanced filtering. There are many more ways to filter packets. After all, in any real life situation, we would need to filter through thousands or even millions of packets. It is indispensable to be able to express the exact packets to display. For example, you can limit display packets to those smaller or larger than a certain length, greater than length, less than length. We recommend you check the PCAP filtering manual page by issuing the command man PCAP filter. However, for purposes of this room, we will focus on Advanced options that allow us to filter packets based on TCP flags. Understanding TCP flags will make it easier to build on this knowledge and master more advanced filtering techniques. Binary operations. It is worth visiting binary operations. A binary operation works. Zeros and ones. Operations take 1 or 2 bytes, returns 1 byte. Let's explain in more depth and consider the following 3 operators. And I forgot what that's called in the explanation. Woo! I have to read back over this one. This one is pretty in depth. Man. All right. Let me lock in. Just based on the contents header. All right. The purpose of this section is to be able to filter packets based on the contents of the header byte. Consider the following protocols: ARP, Ethernet, ICMP, IP, TCP, and UDP. These are just a few networking protocols we have studied. How we can tell TCP dump to filter based on packets on the contents of the protocol header bytes. We will not go into details about the headers of each protocol, as this is beyond the scope of this room. Instead, we'll focus on the TCP flags. Using the PCAP filter, TCP dump allows you to refer to the contents of any byte in the header using the following syntax. Proto, it refers to the protocol, for example, ARP, Ethernet, ICMP. So what exactly you're looking at, what protocol. EXPR indicates the byte offset, where 0 refers to the first byte. EXPR indicates the first byte offset, where 0 refers to the first byte. Okay. Size indicates the number of bytes that interest us, which can be 1, 2, or 4. It is optional and is 1 by default. Okay. Applies to end. True. The result is not equal to the number 0. The purpose of this filter is to show packets sent to the multicast address. Cast address, Ethernet address is a particular address that identifies a group of devices intended to receive the same data. And the IP header and compares it with the hexadecimal number. You might spend a little time on this one. This one kind of threw quite a bit at me, and I'm still trying to digest some of this Ethernet header, but it's okay. First time being exposed to it, that's why we come back to it. But this is just a filter, so obviously I want to have some level of understanding of this. But at the end of the day, I can look up how to filter based upon whatever assignment or task that I'm given. So if I'm not familiar with how to do an exact lookup, I can always go back to the documentation and read how to do that lookup to make sure that I can get whatever outcome that I am expected to deliver. So I'm not gonna beat myself up or stress or worry too much about understanding this, but this is something that I know that I'll have to kind of become more familiar with, because this is pretty involved. Where if you find the above two examples complex, we included them so you know what you can achieve with this. However, fully understanding the above examples is not necessary to finish this task. Instead, we focus on filtering TCP packets based on the set of TCP flags. Again, I totally understand that, because I don't think you need to have all of that as of right now. All right. You use the TCP. Don't worry if you find the above two examples can be included them so you know what you can achieve. And it's set for the task to refer to the TCP flags field. The following TCP flags are available to compare with: sync, TCP acknowledge, finish, reset, push. Based on the above, we can write the TCP dump. Capture the TCP package with only. Oh, this is pretty cool. Oh, we're gonna go through this in a minute. Yeah, buddy. How many packets have how many packets have only the TCP reset flag? So this should be the command. It should be TCP dump -R, and then it should be TCP. Wait a minute. TCP. Um, we want a flags TCP flags, and we're gonna set it double equals to. We want the reset, which is TCP -RST, and the parentheses at the end. Yeah. Uh-oh. Try this again. TCP dump -R. And we need to specify where we're looking. And I think that one is, man, this thing here got me thinking, boy. It's not that one. It is, there it is. Traffic dot pcap, and then to do the reset, it should just be what I had before. TCP dump TCP bracket TCP-RST close bracket. No, this is flags. Sorry. TCP flags. The TCP-RST. WC. Syntax error. What am I missing? TCP dump, right? Yeah, DUMP. Syntax, that's on me. It's telling me syntax error again. TCP dump -R traffic pcap TCP dump TCP bracket TCP flags. Man, they're giving me some problems today. Didn't need the extra dump. So is it 57? Say, man, I'm gonna have to get on Google for this for real. Cool. Man. Didn't want to go down easy, I see. All right. All right. What's this next one? Where's the IP address of the host that sent packets larger than 15,000 bytes? So I remember there was a way you could filter by size. So we know it is TCP dump -R. And then I think, oh, let me do the specify the file traffic.pcap, and then to capture what's larger, I think it's just this was it packet size? Greater. 15,000. Whoa. What is the IP address of the host that sent packets larger than 15,000 bytes? One 68, 124, 137. Is that it? Nope. So in my eyes, did I not go down far enough? Uh, mm, let me see something. I think there's got to be a way I can filter down some of these commands. I think this should be it. IP address 185.117.80. 53. And that's the port number, maybe? Okay. Cool. Cool. All right. The next task is displaying packets. Hey, how's it going, everyone? Just spending some time working through these TryHackMe.com modules as they are working me, I should say. So the next one is displaying packets. TCP dump is a rich program with many options to customize how the packets are printed and displayed. I've selected to cover the following 5 options. Q, quick output, print brief packet information. E, print the link level header. A, show packet data. D, ASCC2. To demonstrate how the above options manipulate the output, we will first display 2 captured packets without showing any additional arguments. 2 packets.pcap, brief packet information. Prefer shorter output lines. You can opt for a quick output with -Q. The following example shows the timestamp along with the source and the destination. So, well, what's the difference between the two? Oh, okay. This has the act number when. Okay, it's got a few more information. Okay, I was going to say, man, darn, this thing looked long too, but I see the difference between the two. If you're on an Ethernet or a Wi-Fi network and want to include the MAC address in the TCP dump output, all you need to do is add the -E. This is convenient when you are learning how specific protocols such as ARP and DHCP function. It can also help you track the source of any unusual packets on your network. Two packets -E. Displaying packets as ASC2, which stands for American Standard Code for Information Interchange. The ASC2 code represents text. In other words, you could expect the -A to display all the bytes mapped to the English letters, numbers, and symbols. That is what this looks like. All right, so with this one, seems pretty straightforward. TCP dump dash R for root. And then what we want is to get the IP address, or excuse me, get the MAC address of the host that sent the ARP request. So this one is working with, is it the same file? Which is, I think it is traffic PCAP. I didn't see it specify anything any different. So let me find that. Yeah, traffic PCAP. And if we can't figure this thing out, we'll jump on Google. But traffic.pcap, and then we just want ARP. It just wants the MAC address. Assuming this is 52.54.00.23.60.2b. Uh-oh, we provided an answer that might not be in English, so it's wrong. All right. Let's see. What is the MAC address of the host that sent an ARP request? Include the MAC. There we go. Let's try this one. I think last time, well, clearly I didn't include the E, so I think that's what it was. So 52, 54, 007C, D3, 5B. Hey, there we go. And the conclusion. In this room, we have covered the various TCP dump options along with Wireshark and T-Shark. TCP dump is an excellent tool for better understanding of network protocols. We kept this room level easy. However, we showed much of the TCP dump's power, especially when you have sift through thousands and millions of packets. Yes. Kept it easy, huh? That what you like to call easy? Woohoo! Go us. In-app basics. Port scanning, who's listening, version detection. So look, let's spend a little bit of time with this. Excuse me. Thank you. All right. So let's start to supplement some learning. All right. Pings mostly my own on the importance of being and other things. DNS TCP dump. For my class on system administrations, I often use a homework assignment requiring students to capture and analyze TCP dump output to help them understand how the DNS works in detail. This is accompanying the lecture notes in which we do go through packets from the server to the roots, etc. But after grading the assignment, I often provided additional and repeated explanations to help students understand what they should be able to get out of the assignment. This post serves as a sample solution that I hope is useful to others in understanding a little bit after both the DNS and TCP dump. This is not going to set up an AWS EC2 instance using this domain. Configure the DNS resolver is as trivial as adding name yes, replacing the name server line, allowing any query to recurse as well as listen on it. Next, we begin capturing the network traffic, including SSH traffic, which we are not interested in and which we'd otherwise see a fair bit of since we are logged in via SSH, followed by a simple DNS lookup. So it looks like he's doing a TCP dump, and he has the -W flag. So he's looking to write packets to a file, and the file is located at a temporary file dns.pcap. He has the -I flag to capture packets on a specific network interface. And that is the name of this, seems to be some form of an Ethernet. And he has the port, but he included port not 22. What does that mean? Can I copy this? Where is not? All right, some of you cybersecurity aficionados out there, or network administrator aficionados, help your boy out. What does the not mean? I don't remember covering that additional verbiage, but I might have missed it. Maybe we did cover it in TryHackMe, but I might have missed it. But I don't remember not. But I see he's going on port 22, and the host is yahoo.com. And this is the alias, the address. These are the various addresses for Yahoo, and this is his IPv6 address. And then on his PCAP file, he basically just wrote this information. Okay, there are a bunch of things going on here. Oh, so he describes it. Perfect. There are queries beyond the one we had made. What's up with the dlv.isc.org query? There's a TCP involved. Wait, what? I thought DNS is UDP. And it will take some practice to identify and trim out the relevant packets. You ain't lying, brother. Let's take a closer look as we go through this. Let's play Dig plus Tracy. He's got a good sense of humor. I like that. My first time reading anything from him. By default, bind 8. Let's configure validation enable as shown. Let's config. Since both the DNS validation with the sidebar are enabled by 8, we will use certain defaults for the initial trust anchors, which in this version of bind 8 still includes the use of dlv.isc.org and the DLV zone. As a result, our very first query to one of the root servers is for the DNS key resource record. And that is the response back. So queries made so far do not have anything directly to do with the lookup of our hostname, yahoo.com. The first query relevant to this lookup with fields annotated as per line as per the TCP dump manual is this. That is our query goes to m.root-servers.net with one additional RR section in the query. Which is a bit larger than the 13 needed for yahoo.com. However, if you pass -v-read TCP dump, you can get a little bit more information, as you may find that the DNS server also adds an additional pseudo DNS record type to support the eDNS particular. Line 8 uses the eDNS option code 65,001 to send and process so-called sources identity tokens. Okay. Woo! Man, this might be I'm following it to an extent, but we may come back in and read this one a little later. But who is this though? I like the blog. Well, I'm just a Zest guy, you know. This is just another boring personal website. I don't have Facebook for obvious reasons. You can find me on Mastodon, LinkedIn, and here's his local resume. Let's see who this is. Jan Schumann. What does your website look like, brother? Let's look at his blog and his personal website. So he does quite a bit of writing, and he's bilingual too. Man, nice. He's a pretty smart brother. Speaks 3 different languages. I don't say how we got mutual contacts and I ain't even logged in. But okay, I think that's just default. Let's check him out. So this is his blog. And this is his website. Okay, so it's pretty simple, but I like it. I could dig it. I'm gonna check him out. We're gonna hold off on what he wrote for right now. It's a bit much. Let's move this over here. But I did want to take a look at this security research tool tutorial, TCP dump examples. Now this is a bit dated, so I hope it doesn't appear to be too much that's changed from what I just learned and what it currently has displayed now. But we're going to read through it and just make sure TCP dumping, practical TCP dump examples to lift your network troubleshooting and security test game, commands and tips to not only use TCP dump but master ways to know your network. Knowing TCP dump is an essential skill that will come in handy for system admins, network engineers, or security professionals. TCP dump examples. So is this a separate link out, or is this the same site? And this is just, yeah, it's the same site. Okay. So it is covering quite a bit, 20 different practical examples or techniques that you can look into. And we'll kind of walk through these and make some notes. I was hoping there was and I may just install this on my machine myself, some form of if I can install this tool and do some practice with these commands and how to utilize them most efficiently, so I can get comfortable with it and just have a good understanding of what to do and how to navigate it. Select the interface that capture used to take place on this often. Common parameters often seen in TCP scalpel, pseudo TCP dump. The I represents capture all the packets on a specific network. You're using Ethernet. The -NN don't resolve an IP address and don't resolve protocol numbers. Oh, we got it right here. I select interface that capture is to take place on. This will often be an Ethernet, car, or wireless adapter, but could be a VLAN or something more unusual. Not always required if there is only one network adapter. NN, a single N will not resolve host names. A double name will not resolve host names on ports. This is handy for not only viewing the IP port numbers, but also when capturing a large amount of data, as the name resolution will slow down the capture. The SO snap length is the size of the packet to capture. SO will set the size to unlimited. Use this if you want to capture all the traffic. If needed if you want to pull binary files from a network. The verbose, I'm not familiar with this one, so we'll continue to read on. Verbose using -V or VV increases the amount of detail shown in the output, often showing more protocol specific information. Port 80, of course, the port number to capture the only traffic on port 80. This is, of course, usually HTTP. Adding the -A command will have output included the ASCII strings from the capture. This allows easy reading for the ability to parse the output using grep or other commands. Another option that's shown that shows both hexadecimal outputs and ASCII is the -X option. TCP dump -A. Due to this output, snap is the size of the packet to capture. We'll set the size to unlimited. Use this if you want to capture. Okay, so you would typically specify the traffic that you want to capture, but for this one, the -SO is going to capture it all, and then you're doing it on port 80. Got it. See, that's why it's good to reinforce what you just learned. Tend to pick up on things that way. Capture on protocol. Filter on UDP traffic. Another way to specify this is to use protocol 17, that is UDP. These two commands will produce the same result, the equivalent of TCP protocol 6. Sudo TCP-I, Ethernet, and you're looking to get UDP, and the -I was to get all the incoming packets. So what's the difference between, what is the difference between -I and -S0 and TCP dump? Okay, so The dash I is going to work on a specific network, wherein the dash SO is going to return a unlimited size, if you will. So there is no gatekeeping to a specific size. That's what I've captured so far. But any aficionado out there, look, feel free to help your boy out now. Help your boy out. Capture on the protocol, capture host based on IP address. Using the host filter will capture traffic going to a destination and from the source, the IP. Using the host filter will capture the traffic going to the destination and from the source IP. So hosts will give you information going both ways, from the source and to the destination. Alternatively, you can capture only packets going one way using the SRC or DST command. In a -W, we just learned that we'll write to a file. A standard PCAP file is a common option. Writing a capture file to a disk allows the file to be open in Wireshark or other packet analyst tools. So looks like you would write it to a file and then bring it into Wireshark in order to do a further investigation on whatever specific packet that might look suspicious that's on the network, or if you want to just dissect it further to see what additional information you can capture. You will write it to a file using some form of this command, sudo TCP the dump I, which is going to capture everything. You're looking for the interface, no specific size, and the -W, you're going to write it to this particular file. Got it. Next up, we have the line buffered mode. Without the option to force the line buffered or packet buffered C, you will not always get the expected response when piping the TCP dump output to another command such as greep. By using this option, the output is sent immediately to the pipe command, giving an immediate response when troubleshooting. So you just add it at the end. And this is what allow you to combine those filters. Throughout these examples, you can use the standard logic to combine different filters and or. here's some additional commands, practical TCP dump examples. In these examples, there are a number of ways that the result could be achieved. As seen in some of the examples, it is possible to focus the capture right down to the individual bytes in the packet. That method you will use will depend on your desired output and how much traffic is on the wire. Capturing a busy gigabit link may force you to use a specific low-level packet filter. When troubleshooting, you often simply want to get a result. Filtering on a port and selecting an ASCII output in the combination with grip cut or op will often get that result. You can always go deeper into the packet if required. For example, when capturing HTTP requests and responses, you can filter out all packets except the data by removing the send ACK event. However, if you're using grip, the noise will be filtered anyway. Keep it simple. So this is just going over some examples of it and what to expect with it. Capture on the HTTP get and post packets. Going deep on the filter, we can specify only packets that match get. The post request, not the post data, not included in the packet captured. With this filter, it is likely that a post request will be split across multiple TCP data packets. That would make sense. The hexadecimal being matched in these expressions matches the ASCII for getting post as an explanation TCP. Woo! Parse host HTTP request location from transfer by not target input. So this thing has quite a bit of shortcuts and ways that you can dissect and filter down to what it is that you're looking for. And I'm sure in time and with practice, we can figure all of this out, but I'm not going to spend too much time on trying to understand those packets. I want to spend some time and dig in on breaking down how this works, because I think a lot of times we get caught up in getting done what we need to get done, but we don't have a very thorough understanding of the ins and outs of how it works, which would only make us better at whatever respective technology or skill or industry that we're working in. So this one is the HTTP request, foundation of data communication on the web, protocol that allows web clients like your browser and server to exchange information. So the HTTP defines how the data of the web pages look. So we're pretty familiar with that. It's stateless. Each request is treated independently, and the server doesn't retain information about the past interactions. It follows a request response model. The client sends a request, the server responds with requested content. HTTP request is a message sent by the client, typically a browser or mobile app, to a server asking for a specific resource or action. When you hit an endpoint, get API users, your client sends a request to the server. That request contains multiple layers of important information.